So let's say we've given this vector u, and we've asked to find the length of the vector, that is the magnitude of the vector, and let's say the vector in component form is 3, 6. So we can find the magnitude of this vector, and it's going to be given by 3 squared plus the 6 squared, and we take the square root of it, and that's going to be gives a value of 9 plus the 36. The square root of that equals the square root of 45. So quite straightforward finding the magnitude of a vector whenever the vector is written in component form. So let's say we're given this vector here, and this is vector w, and we're told that we go along 3 and we go down 4, and we're asked to find the magnitude of this vector. So we could write it in component form. We could say w is equal to, well, we come along here, so a distance of 3, and we're going to come down a distance, so it's going to be minus 4. And the magnitude of this is going to be equal to the 3 squared plus the minus 4 squared, and we take the square root, and that's going to give us a value of 25. We take the square root of it, will give us a value of 5. So the magnitude of that vector is a value of 5. So quite straightforward finding the magnitude of the vectors. Now let's say we're given a vector u, and we're given a vector w, and we're asked to add these two vectors together. So let's say the vector v is equal to the vector u plus the vector w, and we want to find that vector v. Now let's say, for instance, we're also told that the distance along here is going to be a distance of 2, and we go up 3, and say in this vector here we go along 1 and we go down 2. So we could write these two vectors in their component form. So we could say that the vector v would equal, well, the vector u is going to equal in component form 2, 3, and the vector w in component form is 1 minus 2. And then we simply add the 2 plus the 1 gives us a 3. 3 plus minus 2 is a value of 1. So the answer to this is 3, 1. So the vector v is given by 3, 1. Now we can see what's happening here physically if we were to actually add these together. So we would be adding them nose to tail. So we could have vector u, which comes up here, and we're going to add the nose of this one to the tail of the other one. So the tail of this one here is this point. So we could take this point here and shift it to this point here. So we'll have a vector that runs down something like this. So this will be our u, this is our w, and the resultant vector, that is the vector we get when we add both of them together, is this vector v. And you can see the vector 3v here is we go along 3 and we come down a value of 1. So this is the graphical or geometric representation of the algebra which we're doing here. So let's say we're asked to find the vector u minus the vector w. So let's say v equals u minus w. How's this going to change what we have here? Well, let's rub some of this out first of all. We don't need this here, and we don't need this here for the moment. So now the vector u minus the vector w, well, we can do it in component form. We can say the vector u is 3, 2 minus the vector w, which is 1, 2. So in component form it's quite straightforward. 3 minus the 1 is 2. 2 minus the value of, that should be minus 2. 2 minus minus 2 is equal to a value of 4. So this here is now V equals U minus W. So you can see in the component form it's quite straightforward to add and subtract the vectors. So in the geometric form here, what's happening is we've got vector U, which is our 3, 2. Now we're going to have a vector which is going to be minus W, so we're adding on minus W. So a vector of minus W is the same as the vector as W, that's the magnitude is the same, but it points in the opposite direction. So that vector there points in that direction, and the minus W points in that direction. So it means that whenever we add these two vectors U and minus W nose to tail, we're going to get a vector that comes up in this direction here, which is our vector U, and we're going to have our vector W added nose to tail, so it's this one here added on at this point here. So I add this on at this point here, and this is going to be our minus W. So whenever we add those on, the resultant vector is a vector that goes in this direction here. So this is now our vector V, and our vector V is along 2 and up 4. So now we're going along 2 here, and we're going up 4 there in order to get this vector V. So thank you for listening. I'll get you in the next video. Goodbye.